question. Right, okay, well, we will discuss this question later, but let us start a new chapter. Uh, right, and first we'll talk about okay, Shahid, yeah. So yeah, on Thursday, okay, so Tariq is still not here, so let us yeah, we should start and whatever you have done in the CPSC portion, I will just directly write. Right, and whatever is there in the JEE portion, which is extra, so that I will derive. But whatever you have derived in the CPSC portion, such as the drift velocity, the relation between the current and the drift velocity, mobility, all the other things, so I will not, I will directly write those limits. Right, Shadi? Sorry, it is not. Let us, yeah, let us then. Okay, so what is electric current, right? And now, as we have done this eighth chapter, so you have done this electromagnetic waves, right? Did you complete that chapter? Yes. Hello, Chavez, can you hear? Yes, Chavez, can you hear? There is some issue with your internet or mic, I don't know. So can you hear me, Chavez? Uh, yes, hello. Yes, Chavez, can you hear? I guess maybe your internet is not working properly or the microphone with some problem. Yes, yes, Chavez, are you there? Yeah, can you let me write it in the chat box if you are listening or not? Maybe there is some problem. So, and yes, hello. Oh, someone is calling you. Yeah. So, okay. So now can you, yeah, can you speak?
Yes, sir. Yes.
Yeah.
Sorry, sir. Someone called me.
Yeah. So no worries. So now, as we have done already the eighth chapter, electromagnetic waves, right? So you saw that we are saying that flow of charges produces current, right? But in your eighth chapter, you also learned that what did you learn in the eighth chapter? Can you recall?
Sir, alternating current.
No. So electromagnetic waves. In the electromagnetic waves, you learned about those Maxwell's equation, four equation, right? So in
Yes, sir. Displacement current.
yeah. So you see that we are saying that flow of charges. We are saying that flow of charges produces current. But in the case of displacement current, we have seen that the change in electric flux also can produce the current, right? So now in here we are actually talking about conduction current. Is that clear? Right. So whenever we are saying that flow of charges produces current, so that is actually the conduction current. So we have two kinds of current. One is
Sir, can you repeat?
yeah. So I am saying that you already saw that in the eighth chapter, electromagnetic waves, right? We saw that not only the flow of charges, but the change in electric flux also can produce the electric current. So in here, when we are writing flow of charges produces current, so that is only for the conduction current, right? But in case of the displacement current, we have seen that this is change in electric flux. So this displacement current is due to the change in electric flux, right? So change in electric flux also produces this current. But as for now, in the third chapter, we will only deal with the flow of charges that produce current. Understood? Is this part clear, Shadi? Yeah. So, okay. So we have two kinds of current. One is average current. Yeah. One is average current, which is change in charge with respect to time. And then we have this instantaneous current, right? So I instantaneous, and that is dq by dt. These are the two currents that we have, right? And we will, in shorthand, we will write this as I. So this is the instantaneous current. Instantaneous current. Now we can also write it in the graphical representation. So if we draw a graph of, let's say, Q and T, right? And this is your behavior. So if you calculate the slope, right? If you calculate the slope of this graph, so slope of QT graph will give you what? This will give you the current, average current, right? Because this will be what? This will be delta Q, this will be delta T. So the slope of QT graph, this will give you I average, right? And from the current and time graph, oh, you want me to scroll up? Yeah, so this part you have already done in your CBSE course, so that is why. So in this chapter, we are mainly focusing on the conduction current. So then we have these graphs, right? So this is a QT graph, charge and time graph, and we can also have this current and time graph, right? So let's say this is the behavior, and if we calculate this area, right? Let's say we calculate the area under this graph. So this would be I into T, and that is what? That is the charge. So area under the IT graph, right? This will give you the charge. Okay. So these are the things that we do. Okay. So now let us do one question based on this graph, right? And then, okay. So we have, yeah. Are you noting it down? So please note down this.
Sir, scroll.
Yeah. Please note down this part. Is even you have noted it down. Okay. So now let us understand this graph. So we have an IT graph, right? So this is the current in ampere, and then this is the time in seconds, right? So this is let's say 5, 10, and 50, right? And then we have this one. So let's say the graph is behaving like this one, right? So this is in. So now let's say this is -5, this is 5, and this is 10. Okay. So the question is that question first question is that calculate the charge from 0 to 15 seconds, right? So this is a change in charge, right? And then second question is calculate the average current. Okay. So to calculate, so this is the change in charge, delta Q, right? So we have this is the behavior of the IT graph. So this is the graph, and we want to calculate the charge. So what should we do in the first question? Calculate the charge. What should we do? Yes, Chavez. We have this current and time graph, right? And we have to find out the
Sir, IT at 0 minus IT at, sorry, IT at 15 and minus IT at 0.
yeah. So we want to calculate the charge from IT graph. So that is area under the graph, right? We just understood. So area under the graph will give you the charge, right? Okay, so we have to find out area under the graph. So this would be the area under the graph. Yeah. So for first question, we have to find out area under the graph. So this will give you delta Q, right? And this is this triangle. So 1 by 2, and this is base is 10, and then this is 10. Mine plus of, let's say this is half, and then this is 5, and then this is minus 5, right? So this is the area under the curve. So this is 5. So this is 50 minus 25 by 2. So this is 50 minus, this is how much? 12.5. So this is zero point 0.5, and then this is how much? 9 minus 2, 7. So 37.5 coulomb. So this is the charge from 0 to 15 seconds, right? And in the second question, we have to calculate the average current. Average current from 0 to 15 seconds. This is the question, right? So that would be how much? So that is average is delta Q by delta T. So this is 37.5 divided by, this is 0 to 15. So 50. So this would be how much? So this is 5 threes. This is 7.3, right? And then this is how much? So this is 2 and point, and this is 4, and then 3 amperes. So this is the current, average current from 0 to 50. Is this part clear, Chavez? Is this question clear? So please note down this problem. If it is clear, please note down, and then we will understand about the
Done, sir.
yeah. Okay, so then the current part is done. Now the next topic is drift velocity. So you have conducting material, and then let's say you provide a electric field, right? So this is the direction of electric field. Then the charges are right. So then the charges are flowing in this direction, because this is the direction of electric field. This is negative charge. So these are flowing in this way, and they will continuously collide, right? And then they collide and they will move in this direction. So they will appear to be like drifting. So let's say this is the electron, so they will collide and then they will move like so whatever is the average velocity with which they are moving, so that is called the drift velocity. And we calculate this drift
This velocity is
velocity.
of all electrons.
Yes, yes. What did you say, Shabe?
Sir, this velocity is of all electrons.
Yeah, yeah. So this is of the all electrons, right? This is the average. That is why I said average velocity with which the particles, right? The particles or the all the electrons move in this conducting material. So that is how much? So that is E and tau by M. So this you have already derived. So that is why I'm not deriving. Just remember that V is U plus AT, right? And acceleration would be, this would be force by M, and F is how much? F is QE, right? By M, Q is minus E. So that is why you have this acceleration. So AT, right? So that is why A is this one, and then you have this tau. And then when you write the magnitude only, so this is EE tau by F, where this tau is your relaxation time, right? Okay, so this was about the drift velocity, and then your drift velocity is related by, so relation between,
Yes,
relation
Golak.
yeah. So this part you have already given, right? So just to remember this one, this is the idea that, so just remember that what would be the acceleration. So this is the acceleration part and this is the time part. Yeah. So now, what is the relation between drift velocity and current that we studied, right? So I will only again write directly the formula. So this is NEAV. So this is how the current is related with this drift velocity, right? And then we have this Ohm's law. So Ohm's law, and this is generally we understand macroscopic. So macroscopic form of Ohm's law, right? So then this is how much? So Ohm's law says that whenever you draw the graph of V versus I, so you will have a straight line, right? Which means that V by I would be constant. So V is directly proportional to I, so you will get V equal to IR. So that is the Ohm's law, right? But there are some materials which doesn't follow this Ohm's law. So they are called non-ohmic material. So for the case of non-ohmic material, this is not like the straight lines. They will behave like this one, right? So VI graph would be not a straight line.
Some junction diodes.
Yes, yes. What did you say? What did you say, Chavez?
Sir, like junction diodes, right?
Yeah. Absolutely right. So the semiconducting devices, junction diode, or the transistors. So those devices. So these are non-ohmic. Yeah. So as you said, junction diode, PN junction, diode or transistor. So these kind of semiconductor devices. Yes. Good. Okay. So now we understood about Ohm's law and ohmic material, and then we understood about non-ohmic material. Then we can. So now we will understand about what is the microscopic form of, right. So, but before that, let us understand about resistance, right? So we have I, which is NEAVD. And we know that this VD is how much? VD is E tau by M, right? So this is NE square E tau by M, right? And then this is E. So if I take this, right? So, and I can write this I as V by L, right? So this V would be, right? This V would be, or no, not this I, but this is I, and I can write electric field as V by L, right? So potential by length is electric, right? So this NE square tau by M A, and then E is V by L, right? So we can see that V is how much? V is M L, and this is NE square tau A and I. So for the for the Ohm's law, what was the Ohm's law? Ohm's law was V equal to IR, right? So when we compare this with this one, so R will come out to be M L and N E square tau E. So this is my resistance, right? This is my resistance. And if I write only these terms, right? So if I write R equal to this term rho L by A, right? So this rho is called, so this rho is called this resistivity, and this rho would be how much? M by N E square tau, right? So this is called the resistivity. Okay, and then we have, yeah, so please note up to this point. This point we have noted it down, right? So this point you have noted it down, right, Shave? Yes, Shave is there. So please note down from, yeah, please note down from. Whenever you have noted it down. Did Shave? Then, so now we calculated resistance, we calculated resistivity. So now what is conductance? Right, what is conductance? So this is, yeah, this is the reciprocal of resistance, right? So resistance was what? Resistance was ML whatever. So this would be NE square tau A by ML. This is conductance, and similarly you will have conductivity. So what is conductivity? This is the reciprocal of resistance. This would be N E square tau by, right? So these are the things, and this is denoted by sigma. Okay, so this part is here, and now let us write about the microscopic. But before we do that, so let us understand about this current density. Right, so this is defined as J, which is I by. So this is your current, right? And this is defined like the amount of current passing through any. This is your current, and this is a vector quantity, right? Okay, so your I is J dot A. This is how the current is defined. Okay, so then we can write the microscopic form of Ohm's law. And what is that? The microscopic form of Ohm's law, we know that I is NEA VD, and VD we already know that is NE and E and tau by M, right? Or this is not N but E. And then what do we have? So this is NE square and E A tau by M. So this is I. And I take this A in this side. So I by A. This is NE square E and tau by M. Right. So this is J, and NE square tau by M is what? NE square tau by M is sigma, right? So that is NE square tau by M. So this is sigma. So J is sigma. This is called the microscopic form of. Okay, so these are the crucial things that we have to remember. And some of the derivation you already did. So that is why I didn't write. So please note down from this part. And then we will do some questions based on this.
Can I scroll down?
Macroscopic is this one. Microscopic is this one. right? Whenever you have noted it down, yeah, so done. So now for the last topic, and then we will do the calculation. So this one is called mobility. Right? So how the charge carriers, how the electrons are moving in the electric field. So that is defined by this mobility. So this is denoted by mu, and this is Vd by E. Right? So we know that Vd is E tau by M, and then divided by E. So this will cancel, and mobility, this would be E tau by M. Right, so this is what we call okay. So this was the crucial terms of the uh, charges flowing, right? Electric current. So now let us do some questions. What is the first question? So let me check the first question.
Can you scroll up?
Oh, so, yeah. Yes, noted, Chavez. Yeah, so you have a question which says that a copper wire of cross sectional area, how much is that? 6 millimeter square on A side, right? Okay, so a copper wire of 6 millimeter area. A copper wire has a square cross section, right? A copper wire has a square cross section area of 6 millimeter side, right? So this is the side, and the area is square cross section, right? So this is 6 millimeter, and this is also 6 millimeter. Now the question is that the wire is 10 meter long, and carrier current of 3.6 amp, right? The density of free electron is 8.5 into 10 to the power 8 per meter cube. So per meter, right? Then you have to find So find first is current density. Second is what? Electric field, and the third one is how much time it is required for an electron to travel the length of wire, right? And resistivity is given, which is 1 point. This is 72 into 10 to the power minus 8 ohm meter. So these are the questions that we have to calculate, right? So what are the things that are given? So area of cross section is given, right? A is
Density.
yeah. So A is given, which is 6 into 6 and millimeter square. This is the area, and what other thing is given? Length of the wire. L is given, and what is the other thing which are given? Current is also given, 3.6, and number density. So number density is also given, which is 8.5 into 10 to the power 28 per meter cube. And also this resistivity is 1.72 into 10 to the power minus 8 ohm meter. Okay, so first thing you have to calculate current density, right? So that would be easy. What is current density? J. What is that? What is current density?
By A.
I by A, right? So I by A. So this is I is 3.6, right, ampere, and this is in millimeters. So we have to change it in meter square. So 6 into 6 into 10 to the power minus of 3 into 10 to the power minus. So this would be how much? 3.6, and this is 36 into 10 to the power minus 3, 10 to the power minus 3. So this is again 10 to the, this is by 10, right? So 36, 36 cancel, and this is 10 to the power 6 divided by 10. So this is 10 to the power 5. And ampere per meter square. So this is the current. What would be the electric field? What would be the electric field, Travis? Yes. What is the electric field?
Electric field J is equal to sigma E.
Absolutely right. Good. So J is equal to sigma, right? And we know that rho is here, right? So please calculate E and tell me how much work it is. Please calculate. And also calculate this, how much time is required to travel the length of the wire. So please calculate this relaxation time also. Please calculate that. Not relaxation time, but the time required to cross this. So please calculate and tell me the answer. Yes, what did you get, Shave? What is the electric field?
Sir, I'm doing.
Yes, sir. Please calculate and do. And then we'll calculate the time required to travel that length of the path.
1.7 into 10 raised to minus 3.
1.7 into 10 raised to power minus 3 Newton per coulomb or voltmeter, right? Anything we can write. So, yeah, let us see that. So, J, we know we have calculated 5, 10 to the power 5, and sigma is 1 by 1.72 into 10 to the power minus 8, and then this would be, oh, so good. So this would be, E would be just multiplication of that, so 1.72 10 to the power minus 3 voltmeter. Good, good, Chavez. And now let us calculate the time required to cross that wire, right? So this is the area of cross section of wire, and right, this is square, and the electrons are moving with d velocity, and this has a length of l, right? So time required to cross this length of the wire would be how much? Distance by the velocity, right? Right, Shaved? What is there? Oh, so we have to end the class. Okay, so yeah, so we will stop it here, and please calculate this part, and in the next class we will discuss this. So please take the screenshot of this question. Okay, please take the screenshot of this question, and the last part we'll do in the next class. Okay, did you take the screenshot, Shari?
Yes, sir.